you've got changes, measurable changes in all the spheres of the solar system, but Mercury, where we don't have data to say one way or the other. You've got extra solar system dust. You've got galactic dust. So it's like the solar system is moving into a cloud of dust, and it's dustier in the solar system than it would be. And those things point in the direction of something that causes the entire solar system to have different conditions at different times. And the interesting question is, Ben, how do you connect that with regular periodicity, right? We've got changes in solar conditions across all of these spheres but Mercury, and we've got a periodicity that is unexplained. What unites those things?
Thank you for asking. Whether they're studying the solar wind from our sun, whether they are doing electric experiments in a lab with a sphere magnet, or whether they are looking at the entire Milky Way galaxy and now several other nearby galaxies, every spinning sphere magnet in an electric field creates a ripple. Now, this ripple comes out from the equator. So if you've got a spinning magnetic sphere in a lab, the ripple is going to come out like this. They detect this in the solar wind going through the equator of the solar system. That hits Earth about every 5 to 7 days, and it's usually not that big of a deal. But it does cause the magnetic field that we detect within the solar wind to flip and flip back and flip and flip back. Again, this doesn't have a titanically huge effect on the Earth. But when you think about what this means at a galactic level, and not only have they studied it,
so wait, I
the magnetic field
it's on
of
me,
the solar wind.
The thing that flips every, did you say 5 to 7 days?
It's the
That's the sun is rotating, because we watch the sunspots come in at the left, move across the face, and disappear on the right. It's rotating in an analogous way to the way Earth rotates. So that rotating sphere in an electromagnetic field is causing this wave, and the periodicity of that wave is, you said 5 to 7 days, is that right?
Approximately 5 to 7 days at Earth's distance. And basically what it means is we go from being exposed more to the sun's northern magnetic fields and then the sun's southern magnetic fields, northern and southern. Now, they have spotted this at the galactic level as well. Several galaxies. They've spotted it, including our own Milky Way. In fact, they know the amplitude of that wave in the Milky Way. It starts off smaller and then gets bigger as it goes out, from 60 parsecs tall to about 180 parsecs tall, which is, more than 100 light years in both directions. So it basically encompasses the entire galactic disk. Even though it's not completely flat, it's not so wide that the vast majority of stars are not getting hit by this rippling outward wave. They also know its thickness. They know that the galactic current sheet, whereas in our solar system they call it the sun's current sheet or the heliospheric current sheet. They know that the galactic one is tens of light years thick. They think it's moving somewhere between 700 and 1,500 kilometers per second outward.
Okay.
That combined with the amplitude tells us it should be hitting Earth at some point, depending on which speed you choose, between every 5,000 to 7,000 years. Right in the middle, there's about 6,000. But more important than the fact that all of the physics says it's there, it should be hitting us cyclically. Let's think about scaling up what we experience in the solar system version to what our solar system experiences at the galactic version. People who talk about a galactic magnetic reversal think it's about going through the equator line, but that's not the case. That's not what happens here in the solar system, and that's not what they detect in the laboratory. It's whether or not you're on the north or south of that wave. And so if you're at a stationary point here, you don't have to move north or south. As the wave passes you, you will have a galactic magnetic reversal of an entire system. So that's starting to explain the magnetic aspects, but here's the other thing. This magnetic reversal point is housed within this sheet, which is an electric sheet, and it is sweeping outward radially through the galaxy. As it's doing so, it's picking up dust. It's picking up dust like an electrostatic Swiffer duster in your home. It's picking up extra neutral atoms pushed along by that dust, and the magnetism and the electric sheet itself is picking up extra charged particles. The charged particles, the neutral atoms, and the dust are exactly what you would need to see. In addition to these magnetic changes throughout the solar system, in order to say, okay, this is working from both sides now. They know it exists in the galaxy and other galaxies as well. They know it has to hit us cyclically. They know this is where the magnetic reversal point is. Here in the solar system, we're basically having a solar system magnetic shift. We're seeing the extra neutrals, charged particles, and dust that you would expect from it. This is the evidence you need from both sides. But there's a cherry on top of this sundae. Because you see, this rippling sheet, according to their physics, should not have the electromagnetic buoyancy to be sustained all the way throughout the galaxy. It needs injections of extra energy here and there. The only way they can make it work are if they somehow include super flare and small nova-like events from the stars that are being hit by it, which will inject it directly into that electric system to sustain it all the way through. Now, this is a problem because there is a 6,000-year super flare cycle on the sun that is beyond anything that scientists normally think about. In fact, this was just discovered a couple of years ago, I think maybe 2019 or 2021. Let me see. Super flares. It's called Statistical Properties of Super Flares on Sun-like. Yeah, there it is. Statistical Properties of Super Flares on Solar-type stars. And I'll just go ahead and I'll read this. I'll read this to you right here. The analysis suggests sun-like stars. The analysis of the sun-like stars suggests that our sun can cause super flares with energies ... up to X 1000 class every 6,000 years. Okay. Well, that's concerning.
Yes,
because
to say the least.
The Carrington event of 1859, and that was somewhere around X 80. Normally, they think something around X 50 would be a solar kill shot. With the weakening magnetic field, that's probably down, if we're talking about one event and not multiple combined. With just one event, you probably need something above X20, X25. And on this exact same 6,000-year cycle, the sun produces an X1000. And it's probably a little closer to a micronova than a super flare. Now, this is where most people become exceptionally incredulous.
Yep.
What are you talking about, Ben? What are you talking about? But this is where the science has been more on my side than just about anywhere else. Should I keep going?
Yes. Let me just say, I'm not going to become incredulous on you. You've established your credibility to discuss in well, I've lost my train of thought, but somehow you have the credibility to propose models that sound fantastic. But as a biologist, I will say, I do have a doubt. Heather and I have discussed your work extensively, and I do have a doubt as we get into this part of your model, based on the fact that things that you see up in the area of micronova and crustal shifts, which we have not yet discussed here, are hard to square with the number of existing species that we have and the locations where we find them. So in any case, I'm absolutely open to hearing the evidence on this, but there is a part of me that thinks the Earth wouldn't look the way it does if catastrophes on the scale you're talking about were a 6 or 12,000 year recurring phenomenon.
Well, so all right, let's we can certainly get to that. Something in terms of a super flare, or let's go with micronova from the sun, and that would actually probably only equate to about an X100 or X200, maybe up to X1000.
So for those who aren't familiar with X, the flare that released a CME this morning, I woke up to an alert from the Space Weather Service. What's it called? So people who want to sign up.
It depends on which one you're using.
I can't remember, but in any case, what we saw this morning was what, an X5, was it?
X3.
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 Yeah.
Okay, so that gives you some sense. X3 is pretty large. X is the largest class, and within there, the number tells you the magnitude, and X3 is enough to give one pause, but it's nothing like X20 or X100 or so.
Correct.
Go on.
So the solar micronova, there are some indications that this has struck the Earth on these cycles. In fact, specifically on those big ones every 12,000 years. A man named Doug Vogt has done a very good job with pulling together and aggregating the information on fission tracks in microtectites and fossils. And some of the isotopes you can't make with a meteorite, you can't make with a volcano, you can't make them in a nuclear reactor. You basically need a nova-level event on the sun. So then that opens the door to at least asking the question, all right, is there something that could make the sun have a little nova? Well, up until April of 2022, the entire world of the mainstream science said, Ben, there's no such thing as a micronova. It doesn't exist. Then in April 2022, they announced, we've discovered micronova, a new kind of nova. By the way, one of 8 new kinds of nova discovered in the last decade. I've made several videos called They Don't Know Nova, and they really don't. And since that time, they've discovered dozens of micronova events, and they're getting better and better at it. But so the question is, all right, what makes a star do this? Because it's very different from a supernova where the star itself explodes. Most micronova and most regular nova, for that matter, are actually recurring events where they go once and then they can go again. There are only 2 things in space that can make a star pop, shed off its outer skin like a snake violently, and cause this micronova. One is a magnetic kick. It needs some kind of a strong magnetic punch. Or you have to dump material onto the star such that it's like blocking the vent or closing your hand around a firecracker. I don't know if you remember that scene from Armageddon. You light a firecracker in your hand and you set it off. What happens? Burn your hand. You close your hand around that firecracker and your wife's going to be opening your ketchup bottles the rest of your life. I believe that is the quote from the movie. But so those 2 things, you either need to have a magnetic kick or you need to dump material onto the star. Well, what's happening to the sun right now? We are getting a magnetic kick from the galaxy.
So because we're passing through the magnetic sheet.
Current sheet.
Yeah.
And we're getting extra material dumped onto it.
That's
in the form of dust neutral gases and those extra charged particles.
Because they've accumulated at the sheet. So you expect these things at the same time.
Like snow on a shovel blade through space. And so the only two ways that we know of to make a star micronova are happening right now to our sun at the exact same time. It is the only way to explain the nova level isotopes in the geology here on Earth, and it's the only way to fix galactic astrophysics and re-inject that energy into the current sheet because of that electromagnetic buoyancy problem. It literally solves 3 problems in one. And now you have to say, okay, this sounds very scary. Now, this is where we could look into things like the sun going dark in religious or mythological stories, and other things like, or how many ancient civilizations were literally terrified of the sun. And of course, that's more circumstantial. But on top of that 3-way coincidence, what else do you call it? I mean, you can't explain the nova level isotopes on Earth.
So wait, let's unpack that for people, because most are not going to understand it. The problem is that all of the heavy elements in the universe have to have been produced through fusion. And there's no mechanism for fusion to happen unless you have immense amounts of gravity to drive the nuclei of the constituent elements together and cause them to fuse. And even that only produces elements in the lighter part of the periodic table. You need incredible pressure. You tell me if I've got anything wrong here, but you've got to have the incredible pressure created in some kind of a nova event to create the heavier elements. So when we find elements that are heavy and we know something about half-lives and how quickly they ought to expire, we can say, well, there must have been the conditions necessary to produce these things within this time period, or we wouldn't have this amount of material. So we can say there must have been some nova-like event, or we don't have this material here, and yet it's here. So there must have been a nova-like event. Is that fair?
That's fair. And those, again, are accumulated in microtektite glass and fossils on those 12,000-year marks. And we really don't find much in between them, except for what is a more constant raining down of, say, iron-60. And we know that's produced in nova events from stars, but that's also at a constant raining down from space. It's all throughout the galaxy. These accumulations occur right on the 12,000-year marks. And
could they have come from somewhere else?
Almost certainly not. Because while the light from other nova events can get here, there's almost no chance that these are coming from other stars' nova events, because most of their particles are never going to get here. We can look out and we can see nova events that happened thousands and thousands of years ago. And yes, they're beautiful nebula, but it's not like they are spread out throughout everything and everywhere. They're coming on a cycle, and that would be hard to do if it's coming from some other star. The particles probably would never get here. And even if they could, they have half-lives that are too short. It would literally take millions and millions and millions of years for them to get here. There's just no way. It could be coming from anywhere other than the sun.
Okay, so what you've got here is a very strong case that you've got materials created in nova-like circumstances that must have come from our own sun.
Correct.
And you have the observation of micronovas on sun-like stars. And so the logical conclusion that you're deriving from this is that our sun does that. And it appears to be on that 12,000-year cycle.
Yes, and in addition to what we've been talking about that geologic evidence, there are 2 ways they know how to make them in space. They're both happening to the sun as this cyclical galactic current sheet hits. The sun's biggest outburst cycle is 6,000 years. Sort of makes sense that, every second one would be something even greater, perhaps at the micronova level. And this is the things like this happening are the only way to fix the galactic astrophysics. So we went from geological to astrophysical, and now remember there's that galactic physics problem where there's not the electromagnetic buoyancy to sustain the current sheet unless the stars that are hit by it are re-injecting energy back into it. So it literally fixes several aspects or open questions in the science. It matches the cycle, it matches the mechanism of forcing that triggers this, it fixes the galactic astrophysics, and it answers the questions about the nova level isotopes here on the Earth.
Well, that has the sound. This is unfortunate because that has the sound of a correct model. When not only does it answer a question, but it answers a bunch of adjacent questions. That's a glorious thing if you're trying to figure out what's going on, and it's a frightening thing in this case because it implies nova level events very close to home.
It does. And I have woken up every day for the last 3 years and scoured the scientific literature and the observational data for something that tells me that this idea is wrong. And at this point, I'm just getting up and looking for the kick in the teeth at this point. You've never met somebody who wants to be as wrong as I do. And maybe one day we'll find it. But at some point, you can only have so many coincidences of physical evidence and timelines and cycles and mechanisms of forcing and interaction of and convergence of all of them from a planetary, stellar, and galactic physics perspective before you say, maybe these aren't coincidences. Maybe this is legitimate.